Let's go. It's another law of exponents. We're doing lesson 4.3, powers of monomials. So first, we want to start off with power of a power. Sorry about the typo. Cross off that S. We're going to explore a little bit before we get started. That's how I like to roll. I know. You just want the roll. Just tell me the rule. Just tell me what to do. Well, sorry, guys. Sorry to disappoint you. We got to figure this out from the ground up. So let's skip down to here. All right. Write as many different equivalent expressions as you can for the following expression. So pause. Try to just write, I don't know, two or three. Okay. Write two or three. Seriously, pause. Okay. And now I'm going to start and see if, I'll check yours when I get back. But what are some equivalent expressions to that? Immediately, I think, well, to the third power means use this whole thing three times. So you could say 5 squared times 5 squared times 5 squared. And looking at that equivalent expression, I would say, oh, well, look at that. It's the product of powers rule here. I'm multiplying a bunch of powers with the same base. So I can keep that base, and I can do 2 plus 2 plus 2, and I get 5 to the 6th. 5 to the 6th. Now, if you put 5 to the 5th, I understand why, because you would probably have added the 2 and the 3 of that original problem. But if you really reason it through, it actually means 3 sets of 2 5s. 3 sets of 2 5s. You see? 1, 2, 3 sets of the 2 5s. All right? So we have a little bit different rule. We're not going to add the exponents this time. All right, now there's so many different ways we could have written it. We could have expanded that one out into 5 times 5 times 5 times 5 times 5 times 5, right? That's 3 sets. I'm going to use 5 squared 3 times as a factor. See, 3 times I'm going to have to use 2 5s. All right, so that's another way we could have done it. Okay, tons of other ways to do it. I could have done something like this. What about this? 5 to the second times 5 to the second times 5 times 5. There's so many ways you can do it. Okay, enough about that. But what do you notice? What do you do? What do you do with these two numbers? 5 to the second, 5 to the third. So 2 and 3, and we get our answer of 6. Okay, so the rule here is that we're going to be multiplying. When you have a power of a power, we keep the base and we multiply the exponents. All right, so here are some examples. In numbers, if we were to do 5 to the second, then 5 to the third, we would keep the base. We go 2 times 3, and our answer is going to be 5 to the 6th. All right, in algebra, if we have a to the m and outside the n, then we get a to the, how do we write variables that are multiplied? We just slap them right next to each other, a to the n. All right, in words, to find a power of a power, keep the base, multiply exponents. All right, let's go. Let's keep it going. I'm going to skip that one. I'm going to go right to here. Use the power of powers rule. So this would be, if I were to write it out and do it the long way, I'd have how many 8 to the 4ths? Go ahead, say it. Hold it up on your fingers. Are you doing it? Okay, I know I'm not there to check on you, but I trust you guys. Right, 3 8 to the 4ths. Right, so that would mean we have 4 plus 4 plus 4, or in other words, 3 times 4, which is 8 to the 12th. So that is our simplified version of it. Or we could just use our law of exponents that says a power to a power. We simply do the power on the outside times the power on the inside. And we get 8 to the 12. So, right, we have one way to do it that's like thinking it all the way out and expanding it. And using our previously learned rules, I could have also done this 8 times 8 times 8 times 8, and then 8 times 8 times 8 times 8, and 8 times 8 times 8 times 8, and commutative and associative, and put them all together, and then I see that there's 12. Okay? So I want you to keep all that in the back of your mind, but you don't have to show all of that. And especially on this one, this would be annoying. I have k to the 7th, and I need to have 5 sets of those 7 k's. So let's just use our rule this time. That's going to be 7 times 5, and that's going to give us k to the 35th. All right, try these ones. Pause, complete these ones. Pause, complete these ones, and then unpause and see if you got the right answer. All right. Keep the base. Multiply the exponents. And that gets me 2 to the 10th. Keep the base. Multiply the exponents. That gives me w to the 24th. And now we're going to work from the inside out. Okay, we have 3 to the 2nd to the 3rd. Okay, so we're going to do this part first. 3 to the 2nd to the 3rd, so that's going to be 3 to the 2 times 3. And we still have that 2 outside. We get 3 to the 6th with the 2 outside. And then we have another power to a power, so we're going to do 3 to the 6 times 2. And that's going to give us 3 to the 12. All right. There we go. So simple rule, but it can get confusing when you're trying to apply it in all sorts of different scenarios, and it gets mixed up with the other rules. So there we go. That's the first part of our notes.